This is SpaceTime, Series 24, Episode 17. Coming up on SpaceTime, the Milky Way warped following a galactic collision, discovery of a new kind of magnetic explosion on the Sun, and Gilmour Space to launch its first orbital customer next year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has confirmed what some people have long suspected. The Milky Way galaxy is warped. The findings, reported in the Astrophysical Journal, are providing scientists with the most detailed look yet at the geometry of the galaxy. Like all spiral galaxies, the Milky Way features a rotating disk of spectacular stellar arms flowing out from a central bulge of mostly ancient stars. Viewed side-on, spiral galaxies are usually thought of being incredibly flat and thin. The study's lead author Jinglong Cheng from the University of Virginia says the usual picture of a spiral galaxy is a flat disk thinner than a pancake peacefully rotating around its centre. But the reality is far more complicated. Astronomers have known for decades that many spiral galaxies actually have disks with slight twists in them, like a potato chip. In fact, these warps occur in about 50 to 70% of all spiral galaxies, including our own Milky Way. However, because the Earth's stuck deep inside the galaxy, along one of those spectacular spiral arms we talked about, astronomers know surprisingly little about the warp in the Milky Way. So instead, they're tracing out the shape of the warp by carefully studying the positions and motions of stars across the Milky Way. The authors used data from the Sloan Digital Sky Survey to obtain the most detailed ever picture of stellar motions around the area of the warp as stars start to move up and down as the warp passes. And they were able to confirm not only the location of the warp, but they also discovered that it's travelling around the galaxy once every 440 million years. Think of it a bit like a wave going around a stadium as spectators stand up and sit down again. To reach their conclusions, the authors used the high-precision Apogee spectrograph on the Apache Point Observatory Galactic Evolution Experiment. Over its almost 10-year lifetime, Apogee has observed hundreds of thousands of stars in the Milky Way. The Apache spectra provides information about the chemical makeup and motions of individual stars, allowing astronomers to separate them into different groups, which in turn allows them to follow the warp separately within different groups of stars. The authors also used the European Space Agency's Gaia Space Observatory, which was launched in 2013 to measure the position, distances and motions of billions of stars. Gaia gave the authors extremely precise distance measurements to millions of stars in the warp field by measuring their parallax, the tiny back and forth wobbles in the direction of a star as Gaia and the Earth orbit the Sun. It's the same effect you get when you hold your thumb out at arm's length and look at it with one eye shut, and then look at it with the other eye shut. Open the first eye, of course. By combining the Apogee and Gaia data, the authors were able to create full three-dimensional maps of stars in the Milky Way with detailed information about each star's position, velocity and chemistry. The analysis shows how the warp is caused by the wave travelling through the Milky Way, causing individual stars to move up and down through the plane of the galaxy as it travels. The authors say the most likely explanation for the warp is an interaction with a satellite galaxy, possibly the Sagittarius dwarf spheroidal galaxy around 3 billion years ago, which created a gravitational ripple. And that ripple has continued to move through the galaxy, forming the wave. This is SpaceTime. Still to come, discovery of a new kind of magnetic explosion on the Sun, and Gilmour Space says it'll launch its first orbital customer next year. All that and more still to come on SpaceTime. Scientists have detected a magnetic explosion on the Sun, the likes of which has never been seen before. In the scorching upper regions of the Sun's atmosphere, a large loop of material called a solar prominence, which was generated by an eruption, started to fall back down onto the photosphere, the visible surface of the Sun. But before it could make it all the way back down, the prominence collided with a snarl of magnetic field lines, triggering a magnetic explosion. Scientists had previously seen the explosive snap and realignment of tangled magnetic field lines on the Sun, a process known as magnetic reconnection. But a report in the Astrophysical Journal claims this was the first seen to have been triggered by a nearby eruption. The observations confirm a decade-old theory and could help astronomers understand a key mystery about the Sun's atmosphere, namely why the Sun's photosphere is a temperature of around 6,000 degrees, but its outer atmosphere, the corona, reaches temperatures of several million degrees. After all, things are supposed to get cooler, not hotter, the further you are away from a heat source. The findings could also help scientists better predict space weather, and may also lead to breakthroughs in controlled fusion and lab plasma experiments here on Earth. A similar type of magnetic reconnection, known as spontaneous reconnection, has previously been observed both on the Sun and around Earth. But this new explosion-driven event, called forced reconnection, has never been seen directly, though it was first theorized 15 years ago. The previously observed spontaneous reconnection requires a region with just the right conditions in order to occur, such as having a thin sheet of ionized gas or plasma that only weakly conducts an electric current. But this new type, forced reconnection, can happen in a wider range of places, such as in plasma with even lower resistance to conducting an electric current. However, it can only occur if there's some type of eruption to trigger it. The eruption squeezes the plasma and the magnetic fields, causing them to reconnect. While the Sun's jumble of magnetic field lines are invisible, they nonetheless affect the material around them, a soup of ultra-hot charged particles known as plasma. Scientists were able to study this plasma using observations from NASA's Solar Dynamics Observatory spacecraft, looking specifically at a wavelength of light showing particles heated to between around 1 and 2 million degrees. The observations allowed them to directly see the forced reconnection event for the first time in the solar corona. In a series of images taken over an hour, the prominence in the corona could be seen falling back into the photosphere. As it dropped, the prominence ran into a snarl of magnetic field lines, causing them to reconnect in a distinct X-shape. Spontaneous reconnection offers one explanation for how the corona reaches temperatures of millions of degrees hotter than the lower atmosphere. Scientists looked at multiple ultraviolet wavelengths to calculate the temperature of the plasma during and following the reconnection event. The data showed that the prominence, which was fairly cool relative to the blistering corona, gained heat after the event. This suggests that forced reconnection may be one way the corona is heated locally. Spontaneous reconnection can also heat the plasma, but forced reconnection seems to be a much more effective heater, raising the temperature of the plasma quicker, higher, and in a more controlled manner. While a prominence was the driver behind this reconnection event, other solar eruptions, like flares and coronal mass ejections, could also cause forced reconnection. Since these eruptions drive space weather, bursts of solar radiation which can damage satellites, affect telecommunications and navigation systems, and black out terrestrial power grids, understanding forced reconnection can help scientists better predict when disruptive high-energy charged particles come speeding towards the Earth. And understanding how magnetic reconnection can be forced in a controlled way could also help plasma physicists reproduce reconnection in the lab. This is ultimately useful in the field of laboratory plasma to control and stabilize them. This report from NASA TV.
In the scorching upper reaches of the Sun's atmosphere, the corona, scientists have just seen a new type of magnetic explosion. The explosion, known as forced or controlled magnetic reconnection, is triggered by an eruption on the Sun, which causes tangled magnetic field lines to explosively snap and realign, shooting out particles and energy. The discovery may help scientists understand a key mystery about how the corona, the Sun's outermost layer, is millions of degrees hotter than layers below it. Previously, scientists had only seen spontaneous reconnection, which is not necessarily linked to an eruption or external forcing on the Sun. The forced reconnection event was clearly visible when the scientists used observations from NASA's Solar Dynamics Observatory to look at a wavelength of light showing plasma heated to 6 million degrees. The data showed a prominence, a large loop of plasma moving up from the visible surface of the Sun, the photosphere. In a series of images taken over an hour, the prominence could be seen falling back into the photosphere. En route, the prominence ran into a snarl of magnetic field lines, causing them to reconnect in a distinct X shape. The data from the event showed that the prominence, which was fairly cool relative to the blistering corona, gained heat from the event. The temperature of the reconnection point was also elevated. This suggests that forced reconnection might be one way the corona is heated locally. The scientists are continuing to look for more forced reconnection events. With more observations, they can begin to understand the mechanics behind the reconnection and how often it might happen.
This is SpaceTime. Still to come, Gilmour Space to launch its first orbital customer next year, and a new record for SpaceX. All that and more still to come on SpaceTime. Gold Coast-based rocket company Gilmour Space Technologies has secured its first customer for the maiden flight of its new Eris orbital launch vehicle. Australian startup Space Machines Company has contracted Gilmour to launch a 35-kilogram spacecraft into orbit next year. Space Machines Company is developing in-space transportation capabilities to insert small satellites into orbit ranging from low Earth and geostationary right through to cislunar orbits. Gilmour's new hybrid-fueled Eris rocket is designed to carry payloads up to 305 kilograms into low Earth orbit, 215 kilograms into 500-kilometre-high sun-synchronous orbits, or 305 kilograms into 500-kilometre-high equatorial orbits. The company is hoping to be launching a rocket every month by 2025. This is SpaceTime. Still to come, another new record for SpaceX. And later in the science report, a new study shows that cancer, chronic kidney disease, diabetes and hypertension are the main comorbidities to death from COVID-19. All that and more still to come on SpaceTime. SpaceX has set another new record, launching and landing the same Falcon 9 booster 8 times. It follows last month's achievement when SpaceX launched a record 143 satellites on a single rocket. The latest mission sent another 60 Starlink broadband telecommunications satellites into orbit, bringing the total number to somewhere around 955. The mission was flown from Space Launch Complex 39A at the Cape Canaveral Space Force Station in Florida.
5, 4, 3, 2, 1, 0.
Stage 1 propulsion is nominal.
Falcon 9 successfully lifting off
Entry is nominal.
from Pad 39A at Kennedy Space Center, carrying our stack of Starlink satellites to orbit. And we are throttling down the vehicle, the engines, in preparation for max Q, or maximum aerodynamic pressure. This is the largest structural load that the vehicle sees on ascent, so slowing down the vehicle helps us pass through the short period.
Max Q.
And there's that call out that we've passed through max Q. Now, in about a minute, we'll have 3 events happening. That'll be main engine cutoff, or what we call MECO, stage separation, and SES-1, which is second engine start 1. Now, MECO is where we shut down all 9 of those M1D engines on the first stage to slow the vehicle down in preparation for stage separation, and that's where the first stage separates from the second stage. First stage will start making its way...
Back is chilling.
First stage will start making its way back to Earth for landing, while second stage continues on its journey with the third event, which is SES-1, or second engine start 1. And that's where we light up the MVAC engine, and it propels the second stage along with these Starlink satellites to orbit. We're just about 15 seconds away from those 3 events: MECO, stage separation, and SES-1.
And MECO.
Stage separation confirmed.
And ignition. And throttle up.
We're waiting on fairing deploy coming up here shortly.
Fairing separation confirmed.
And with that stage separation, that confirms the 8th successful flight for this Falcon 9 booster on ascent. So very exciting. And as a reminder, we will be attempting to recover the fairing halves today with our recovery ships Mystery and Mischief.
The satellites were successfully deployed an hour and 4 minutes after launch. Meanwhile, SpaceX also received clearance from America's Federal Communications Commission to launch 10 Starlink satellites into polar orbits for the first time. The company plans to eventually have some 520 Starlinks in sun-synchronous polar orbits. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has confirmed that cancer, chronic kidney disease, diabetes and hypertension are the 4 main comorbidities leading to death from COVID-19. The global meta-analysis by Griffith University looked at databases Medline, Scorpius, Web of Science and Embase, including 375,859 participants from 14 countries. The findings, reported in the journal MBio, determined that chronic kidney disease was statistically the most prominent comorbidity leading to death from COVID-19. Some 2.4 million people have now died from COVID-19, and another 108 million people have been infected with the deadly virus since it first emerged from its Wuhan, China epicenter in November 2019. A new study has found that COVID-19 patients who suffered a cardiac arrest either in or out of hospital were far more likely to die than patients who were not infected with the virus. The findings, reported in the European Heart Journal, also showed that women were especially affected, being 9 times as likely to die as women without COVID-19. The study looked at records for some 2,000 people who had a heart attack outside of hospital and another 1,000 who had an attack in hospital. Researchers found that overall people with COVID-19 were 3.4 times more likely to die following an out-of-hospital heart attack and 2.3 times more likely to die following an in-hospital attack. A new study has found that too many refined grains could be bad for your heart, but white rice is okay. A report in the British Medical Journal looked at the diets and health of 137,130 people in 21 countries. Previous research had shown that eating whole grains is good for heart health, but this is the first study to show that eating highly processed or refined grains is bad for your heart and chances of survival. Scientists found that people who consumed at least 350 grams or 7 servings of refined grains per day were 27% more likely to die and 33% more likely to suffer severe heart problems, compared to those who ate less than 50 grams of refined grains daily. Archaeologists have discovered one of the oldest animal bone engravings ever found. The 120,000-year-old carving was produced by Middle Paleolithic and Middle Stone Age hominins. A report in the journal Quaternary claims the engravings consist of 6 incised lines found on a bone from a now extinct species of ox. The specimen was recovered from an open-air archaeological site on the western slopes of the Judean Hills in central Israel. A new study has found that Australia's largest telecommunications company, Telstra, has the highest level of 5G coverage, while Optus offers the fastest speeds. Researchers found Telstra's 5G reception was available in 78% of tests, while Optus's 5G worked 48% of the time, and Vodafone's 5G coverage was available in 6% of tests. However, Optus turned the tables on Telstra when it came to speed tests, with the fastest average download speed of 362 megabits per second and the highest single test speed with a most impressive 1,431 megabits per second. Now, by comparison, Telstra's average 5G speed was 295 megabits per second, while its highest single download speed was 904 megabits per second. Alex Zaharov-Reut from ITWire.com says Telstra was able to reverse the situation with average upload speeds of 41.2 megabits per second, just ahead of Optus on 40.2.
So Optus is Australia's number 2 telco, and they've come out quoting a study that says that on average, the 5G speeds they offer in Sydney and Melbourne are 22% faster than Telstra, Telstra being the top phone company in Australia, a bit AT&T in the US. And they're saying that they've had a top speed recorded of 1,431 megabits. Where Telstra fights back is that it now has 50% of where Australians work, live and travel through covered. So it's 1 in 2 Australians. If they have a Telstra SIM card and a 5G phone, then they're able to get 5G in many more places. And if there's only one 5G provider in that area, then that by definition is the fastest 5G you're going to get. But Sydney and Melbourne, 2 huge cities in Australia. Think of New York and Los Angeles in comparison.
Divide by 2.
Divide the number of people, of course, but certainly, in importance to Australia. And Optus is claiming that it has the fastest internet. But Telstra will have 75% of Australia covered by middle of the year. And Optus and Vodafone, our third telco with 5G, they're way behind Telstra in that regard.
And for those people looking for 5G phones who haven't got one yet, the good news is they're getting cheaper.
Yeah, in China, they started around about $200 US each. And that's sort of for entry-level models, and they go up. In Australia, last year, the cheapest 5G phone was $749 Australian. In the last couple of weeks, a company called Realme, it's one of these challenger Chinese brands, they've come out with the 5G phone, the Realme 7 5G, for $499 Australian dollars. So that is a mid-range phone with some premium features at this lower price point, which is sort of trying to undercut Samsung and Apple and everybody else. I mean, there are more powerful phones out there. This is not Realme's most powerful phone, but it's the first sub-$500 5G phone in Australia.
Edge is saying ta-ta.
Yes, this is the original version of Edge, now renamed to Legacy. It was the browser that first came out when Windows 10 launched. But because it was a third browser, it wasn't Firefox, it wasn't Chrome, it struggled to get the attention that Chrome and Firefox did. And Chrome, of course, is the world's most popular browser. Google has the Chromium open source browser project. A number of competing browsers are made on, and Microsoft decided to design the new Edge based on Chromium. So it's so compatible that it's got compatibility with all of the Google Chrome extensions. And of course, Microsoft over the past year has been able to refine and differentiate the browser with some special features that you'd have to have extensions for on other browsers. And they've gone from about a 3% market share to about a 10% market share. So the Edge browser is good. I've used it. I mean, I use Safari on my Mac, but on PCs I've used it in preference to, or in addition to, Firefox and Chrome. And it's a solid browser. Microsoft is back browser space, but yeah, there are still people holdouts that are on Internet Explorer. They're not discontinuing that one, but on April 13, with the big update, the old Edge Legacy browser will be uninstalled, and if you don't already have it, the new Edge Chromium browser will be installed on your machine. It's just part of one of the Windows updates, so you won't have to do anything. I mean, in theory, you should not be using the old Edge Legacy browser anymore. There would be security vulnerabilities, and Microsoft has said that if there are older apps that people have written using the Edge Legacy HTML rendering engine, well, that will continue being developed, at least for the time being. The old browser itself will be gone.
That's Alex Zaharov-Reut from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.